Hello again. This is Bunton with your Visual Functional Mathematics at Level 2, Section 2, Measuring. In today's lesson, we'll look at scale drawings and coordinates. Very, very essential in your design work, in your planning the layout of your house, and other very, very useful activities. So the lesson will cover what scaled drawing is and what it's used for, how to work out scales, how to make scale drawings, what the term coordinate means, and what coordinates are used for, how to read coordinates on a grid, how to plot points on a grid, and plotting points to make 2D shapes. As you can see, all of these terms, all of these sections are related to doing some job that requires designing, drawing to specification, and engineering. The keywords you will come across are scale, drawing, ratio, coordinates, grid, plotting, points, and 2D shapes. There are words you probably have come across during the course of your lessons, but in this particular case, you will be using them and you need to use them appropriately. Let's look at scale drawings. Scale drawings show objects at different sizes. A scale drawing is a way of accurately drawing very big or very small objects on a paper. All the dimensions are reduced or increased in the same way using the scale. The scale is a ratio that tells you what a dimension in the drawing means in real life. For example, the scale 1 to 10 means that 1 centimeter in a drawing is equal to 10 centimeters in real life. So as I said, scale drawings show objects at different sizes. A biology book has a drawing of an insect. The drawing has a scale of 1 to 0.4. The scale 1 to 0.4 means that 1 centimeter in the drawing represents 0.4 centimeters or 4 millimeters in real life. In the drawing, the insect's body has a length of 2.1 centimeter. So in real life, this length is 2.1 times 0.4, which is equal to 0.84 centimeters. Please watch the drawings, look at the ruler and the measurements in centimeters, and you can see for yourself what we're talking about. To continue, the scale could be given with units instead. For example, the scale 1 to 0.4 in the drawing could be written as 1 centimeters is equal to 0.4 centimeters, or 1 centimeter equal 4 millimeters. You might also see the scale giving us a line on the drawing. You'll need to use a ruler to measure the line to find what the real life dimension means. Let's look at example 1 on different sizes. The map on the right is a scale drawing. What is the real life distance between Fleetley and Coniston in kilometers? The scale shows the distance on the map that is equal to 5 kilometers in real life. Use a ruler to measure the line. It's 1 centimeter long. This means that 1 centimeter on the map is equal to 5 kilometers in real life. Please study the diagram and you'll see what I'm talking about. So let's look at the answer to example 1. Now, the measure of the distance between Fleetley and Cornerstone on the map is 2 centimeters. Use the scale to convert the distance on the map to the distance in real life. 1 centimeter is equal to 5 kilometers, so 2 centimeters is equal to 2 times 5 kilometers, which is 10 kilometers. Study the map, please, on the diagram. Scale drawings also shows objects at different sizes. You may need to measure a distance in 1 unit and then convert it to a more sensible unit after using the scale. Example 2. Trevor is buying a new flat. The diagram shows the layout of the rooms. It has a scale of 1 to 150. What is the width of the living room in meters? Use a ruler to measure the width of the room on the diagram. It's 3.4 centimeters. Use the scale to find the real life width. The scale is 1 to 150, so 1 centimeter on the diagram is 150 centimeters in real life. And 3.4 centimeters on the diagram is 150 times 3.4 centimeters, which is equal to 510 centimeters in real life. Finally, convert your answer from centimeters to meters, and this will be done by dividing 510 by 100, which is equal to 5.1 meters. Working out scales. To find the scale used in a drawing, calculate the ratio of the length in the drawing to the same length in real life. For example, the map on the right is a scale drawing. The real life distance between Fleetley and Cornerstone is 10 kilometers. We know that now. What is the scale used to draw this map? Give your answer as a ratio. You're told a real life distance, so you need to measure the same distance on the map. The distance on the map between Fleetley and Cornerstone is 2 centimeters, if you look at the ruler on the right. Both measurements must be in the same units, so convert the real life distance to centimeters. Real life distance is equal to 10 kilometers times 100, which is equal to 10,000. And then you convert the 10,000 meters by multiply by another 100, and you'll have 1,000,000 centimeters. So 10 kilometers have been converted, first of all, to meters, and then from meters to centimeters. Write the scale as a ratio and simplify. The map distance, real life distance is equal to 2 to 1,000,000, which is equal to 1 to 500,000. This means 1 centimeter on the map is equal to 500,000 centimeters, or 5 kilometers in real life. Practice question set 1. Questions 1 to 3. Drew has made a scale drawing of a bog. What is the real life length of the bog in inches? Question 2. Kai is walking in the countryside. He uses a map to find the distance to the nearest village. The distance on the map is 3.4 centimeters. The map has the scale of 1 to 100,000. What is the actual distance to the village in kilometers? Question 3. Shadnan is sailing on a lake. The diagram below is a scale drawing of the lake. The lake has a width in real life of 1.5 kilometers. What is the scale used in the diagram as a ratio. B. Sectn's position is shown on the diagram. How far is Sectn from the jetty in meters? Please watch the diagrams as you read the questions and try to understand them clearly. Then you'll be able to answer the questions. Let's look at the next question, question 4 of set 1. Simon lives in Oaks. He travels by road to visit his friend Tariq in Sectn. How many miles does he travel? And these are your answers for question set 1. Question 1, 1 inch. Question 2, 3.4 kilometers. Question 3A, 1 to 25,000. B, 500 meters. And question 4, 34 miles. We move on to making scales drawing. If you have to draw an object to scale, first work out what the dimensions should be. That's part of designing. Example, a rectangle has a height of 1.4 meters and a width of 0.75 meters. Draw the rectangle on a grid like the one you see across, using the scale 1 to 25. Each grid squares is 1 centimeter square. The grid is in centimeters, so first convert the dimensions of the rectangle to centimeters. Real life height is equal to 1.5 times 100, which is equal to 150 centimeters. Real life width is equal to 0.75 times 100, which is equal to 75 centimeters. Remember, 100 centimeters is equal to 1 meter. Next, the scale 1 to 25 means that 1 centimeter on the grid should represent 25 centimeters in real life. The drawing will be smaller than the real life thing, so you need to divide by 25 to get the drawing's dimensions. Drawing height is equal to 150 divided by 25, which is equal to 6 centimeters. And then the width is equal to 75 divided by 25, which is equal to 3 centimeters. And your scale drawing should look like the drawing on the right. Practice question set 2. A scale drawing of Lucy's dining room is shown below. The real-life dimension of Lucy's fireplace are 200 centimeters by 50 centimeters. What is the scale used in the drawing as a ratio? Lucy has bought a new table for the dining room. She wants to know where to put it. The table is 1.5 meters wide and 2 meters long. There should be at least 0.5 meters all the way round the edge of the table. Using the correct scale, draw on the diagram where Lucy's table should be, the correct position. And your answer for practice question 2. Question 1A, 1 to 100. That's the scale. And then B, the table can be anywhere in the shaded area below. It should be 3 squares wide and 4 squares long. You're getting it now, aren't you? Let's look at coordinates now. And first, the coordinate grid. What is it? You can plot points and draw lines or shapes on a grid like this one on the right. It's made by 2 lines crossing that we call the axis. The x-axis goes from left to right and the y-axis goes from bottom to top. We usually say X before Y, enter before going upstairs. And then Point 5. Every point on the grid is described by a pair of coordinates, x by y. The x coordinate always comes first and the y coordinate always comes second. So you enter before you go upstairs. Reading the coordinates on a grid, you need to know certain facts. You need to be able to find the coordinates of the points marked on the grid and follow these guidelines. First, to find the x coordinate, go straight up or down from the point to the x-axis. And to find the y coordinates, go straight left or right from the point to the y-axis. And write the coordinates in brackets with x coordinates first and y coordinate second. Learn these rules or guidelines. Example. What are the coordinates of the point A on the grid below? To find the x coordinate, start from A and go down to the x-axis. Read off the number there, it's 3. This is shown by the blue arrow in the diagram. To find the y coordinate, start from A and go left to the y-axis. Read off the number there, it's 2. This is shown by the green arrow on the diagram. So the point A has coordinates 3 by 2. To plot the point on a grid, you can plot it if you are given its coordinates. So, read the next 3 guidelines and make sure you keep them in your mind. Move left or right from the origin to find the x coordinates on the x-axis. Move up or down until you're in line with the y coordinates on the y-axis. Mark this point. That is your coordinate. Example. Point the plot -2 by 3 on this grid. First, move left from the origin to find -2 on the x-axis. Look at the arrow, please. Move up until you're in line with 3 on the y-axis. Mark this point. Practice question, set 3. 1. Look at the grid on the right. Which of the points A to E is at -3 by -1? Question 2. Look at the grid on the right. Write down the coordinates of point A, B, B with the capital. On the same grid, plot the following points. C capital is equal to -2 by 3, and D, the coordinate D is equal to 3 by -4. And your answers for practice question set 3. Question 1A is E and B is A. Question 2A is 1 by 2, that's the coordinates. And B, the coordinates are -3 by -2. Study the diagram and make sure it makes sense to you, please. We now look at how to plot points to make 2D shapes. You can join up points on a grid to make 2D shapes. For example, a square has been drawn on the grid by plotting 4 points, 1 for each corner, and joining them up with straight lines. The square is named A, B, C, and D after the letters used for its corners. You may need to plot points to complete shapes that have dimensions given in a question. For example, the points A and B on the grid below are 2 corners of a triangle A, B, and C. The triangle has an area of 10 centimeters squared, what could be the coordinates of C? First, the triangle ABC will have an edge between A and B. Use this edge as the base of the triangle. Each square on the grid is 1 centimeter. By counting the squares between A and B, the length of this base is 4 centimeters. Watch the keys, study the diagram, and make sure it makes sense to you, please. So the solution. The formula for area of a triangle is base times height divided by 2. Write the values you know, which is 10 equals 4 times height divided by 2. So 4 divided by 2 is equal to 2. And so 10 is equal to 2 times height. You multiply 2 by 5 to get 10. So the height must be 5 centimeters. Then count 5 squares up from the base. Any point within y-axis 3 will work. So point C could have coordinates 0 by 3. Then we look at practice question set 4. On the grid, find the coordinates of points C and D such that the rectangle ABCD has a perimeter of 16 centimeters. Remember perimeters. And that is your diagram. The key, 1 square is equal to 1 centimeter square. And your answer to practice question set 4. Question 1, C is equal to 1 by minus 2, that's the coordinate, and D is equal to 1 by 3. As you can see, working with coordinates it can be a little bit confusing, but go through the lesson again, walk through the examples first before you try out the practice questions. And then check your answers. If you get it wrong, go through it again until you get it right. Okay? There will be some question and answers videos coming up which will help you with some of these things. So let's look at our lesson summary for what we've learnt. You've covered the following: what scaled drawing is and what it is used for, how to work out scales, how to make scale drawings, what coordinate is and what it's used for. You've also worked out how to read coordinates on a grid. You've also covered how to plot points on a grid, and you now have learned about plotting points to make 2D shapes. And finally, please attempt all the practice questions. If you got them right, celebrate the usual way. It's good. If you didn't get all of them right, it's not a big deal. We learn by our mistakes. Just find out where you went wrong, do the correction, discuss it with your friends if you have to, and all will be well. Next week we'll look at the internal angles of triangles and quadrilaterals. Until then, take care of yourselves, work hard, and achieve. I'll see you then, and thank you. Bye.